Hi everyone, myself Dr. C.H. Naveen Reddy, Assistant Professor, Department of Mechanical Engineering. So today we'll discuss about Mechanical Engineering Design subject. In that subject, Introduction to Mechanical Engineering Design. So it is what is Mechanical Engineering Design, what is the need for Mechanical Engineering Design, and what are the phases of mission design or Mechanical Engineering Design. So we will discuss today these topics. So first of all, what is the importance of the mechanical engineering design? So it is also called as a mission design. So it is very important in the mechanical engineering discipline. So why? Because we design any component, it should be require what are the geometry of the component and analysis of the component with respect to the strength and material selections and manufacturing perspective. So what is mission design? It is defined as the application of scientific principles, technical knowledge and creativity or imagination to design missions that perform specific function with maximum efficiency and economy. So nowadays everyone can talk about while it is designing any component or any system. So we'll talk about what is efficiency. So everyone can design maximum efficiency and with economy. So it is nothing but low cost. So with good materials components. So here mission design includes scientific principles. So it is nothing but we are using certain principles and certain properties to design components, and technical knowledge. So whether the component is satisfy the needs or not, we are using a technical, and creativity. So nowadays imagination is more important than knowledge. Why? Because we can design any mechanism. First, instead of doing directly for design, so first you should imagine so how the mechanism is there and how the mechanism will work. So that is the reason why creativity is nothing but imagination. It is more important than knowledge while designing any components in the missions. So what is called mission and mission design? So what is a mission? So mission is nothing but it should be converts some energy into the other form of energy. So it is nothing but it should be convert input energy to the output. So it is nothing but a useful output. And what is a mission design? So it is nothing but engineering design process to create missions to meet desired requirements, involving planning and analysis, materials selection and component design. So in the design includes all parameters. So it is nothing but planning of the designs and analysis. So it is nothing but whether it is a satisfy the needs or not, and material selection, and also what type of manufacturing method we can use for the manufacturing, and component designs. So what is the mission design? So it is very important for the engineers. So it is nothing but creation of new missions. So it is nothing but innovation and advanced systems. So while it is a creation of any new mission, so it is nothing but innovation and advanced systems. And other case is improvement of existing missions. So nowadays many of them are doing so while improving performance of any mission. So they are using a improvement of already existing missions. So it is nothing but better performance, efficiency and cost reduction. And last one is implementation of ideas. So it is nothing but theory to the practical application to the final product. So this is the three very important one. So it is nothing but creation of new missions, improvement of existing missions, and implementation of ideas. So this is nothing but definition of the mission design. So next we'll move to the what are the basic prerequisites of the design. So it is generally this mission design. It is in the third year, either it is a first semester in that college. So what are the prerequisites? So before that many subjects are completed regarding this basic subjects. So one is mathematics and basic sciences. So it is essential for problem solving and analysis. So it is nothing but many of the times we are finding certain parameters in the any component. Let us take a bolt. So we are finding the diameter of the bolt. So we can use certain basic mathematical principles that is essential for problem solving and analysis. And statics and dynamics. So it is nothing but engineering mechanics, crucial for understanding forces and motion. So it is nothing but we can draw the free body diagrams of components. Let us take any gears or shaft we can draw the free body diagram while it is in a static condition or while it is in dynamic condition. So it is dynamic condition, we can use the D'Alembert's principle. So it is crucial for understanding the forces and motion of the components. And next is the thermodynamics and heat transfer. So it is nothing but while we can important for energy efficiency and thermal management. So we can design any cylinder, piston, connecting rod, crankshaft. We can talk about the energy point and efficiency and thermal management. And next one is vibrations and fluid mechanics. So it is a crucial role for designing any stable system and efficient system. So it is nothing but we can design any damper suspension system. So it is nothing but a spring mass system or any damper system. So it is very important for the vibrations. So it is nothing but free vibrations, forced vibrations. Again, it is a free undamped vibrations, forced damped vibrations, forced undamped vibrations, and fluid mechanics. So it is nothing but very important for the fluids. Very essential for while designing a bearings, especially journal bearings. It is very important for the selection of oils, SAE, Society of Automobile Engineering, SAE based oils. So these are the basic prerequisites of the design. So it is nothing but mathematics and engineering mechanics, mechanics of solids, thermodynamics and vibrations. So these are the very prerequisites for the design. Next is selection of standard components. How we can select the standard components. A designer should always prefer selecting standard components from recognized design data sources instead of designing from scratch. So nowadays we can majority of the times we can design a components instead of from scratch. We can use already some existing designs. We can modify according to the user needs. So it is nothing but component selection strategy based on the let us see the four quadrants. So it is nothing but custom design, low effort, and standard component and high effort. So these are the four components: custom design, low effort, standard component, and high effort. So what are the four parameters? One is called quick design and leverage standards, novel design, and complex integration. So what is called quick customization? So nowadays many of them are talking about customizations, customization of product. So it is nothing but modifying existing components. So it is nothing but they were using some standard template and modify the existing component. So it is called quick customization. For example, let us take change the dimensions of existing wall bracket. Okay, so or maybe change the dimensions of any component in the automobile or any case. So it is nothing but modify already existing component dimensions. So it is nothing but they were using some adapt standard template and according to that modifying the existing dimensions. So it is nothing but quick customization is under low effort and custom designs. So this is very important for the custom design versus low effort. They were using called a quick customization. And second one is called leverage standards. So in generally in academics, many of the times we are using a leverage standards. So it is nothing but use already standard components. Okay, so it is nothing but selection of the standard component dimensions. So we can use some standard design data books. So it is already existing in the market. Some standard design data books are there. PSJ data book, CMTI, Centrally Manufacturing Technology Institute handbook, and Westerman tables, and already some other data books also there, VB Bhandari. So this all data books, it is nothing but already it is following some certain standards. According to the standards, we can select the dimensions of the any component. So let us take diameter of the bolt. We can, according to the diameter of the bolt, we can select the size of the bolt. Let us take M12, M10 bolt, and selection of the bearings according to the applications. Okay, so it is nothing but in that leverage standards, it is low effort, but it is called standard component. So while we can design any standard component, we can use leverage standards. So let us example, we can design any component, let us call bearing, bolt, shafts. So these are all called standard components. We can use leverage designs. leverage standards. So it is low effort under standard component. Next one is called novel design. So it is nothing but invent any new part. So for example, we can create any mechanism for engine mechanism. We can create new mechanism for engines. So it is nothing but invent new part and develop unique mechanism. So it is nothing but it is novel design. It is under called standard component versus high effort. So it is nothing but the engine is a very standard component, but we are using a mechanism is called novel mechanism. We can design a novel mechanism. So that is nothing but example of the novel design. So in that case, standard component, the effort is high. And last one is called complex integration. So it is under high effort and custom design. So it is nothing but integrating many components. So it is nothing but assembly system and combined modules. We can combine modules assemble. So for example, let us take a design a robotic arm. So it is nothing but in that robotic arm, many components should be assembled. So that is nothing but a complex integration under high effort and custom design. So these are the four very important component selection strategy: quick customization, leverage standards, novel design, and complex integration. So in that quick customization, modifying existing dimensions, and leverage standards, we can design any standard components. We can use leverage standards. We are using references are called data books. And novel designs, we can design any new mechanisms. It is a unique mechanism. And complex integration, we can assemble a lot of components in the system. So that is called complex integration. So this is called selection of standard components. And now we'll move to the very important topic is called design phases or methodology. So this is also called as a phases of machine design. So how any component will design, what are the steps it should be follow, it is very important. So what are the phases of mission design? The first is called need or aim, and synthesis of mechanism, or it is also called as a synthesis of mechanisms, and analysis of forces, material selection, design of elements. So it is nothing but design of elements is called sizes and stresses, any modifications, detailed drawing, production. So these are the steps in the phases of mission design. So we will discuss one by one in detail. What is called need or aim? So the design is nothing but it should be satisfy the user needs. So we can design any component or any system. It should be satisfy the needs of the human beings. So that is the reason why first, what is the recognition of need? So this is the first stage where the problem is identified and the purpose of the mission is clearly defined. So it is nothing but, for example, let us see. So nowadays we can talk about any design of low cost systems. So for example, let us take an automobile. Okay, so it should be designed low cost automobile. Let us take a nano car. So it is a very low budget car. So it is who are the users for that car. So it is nothing but a low budget, low income people is users for that car. So whether that car is satisfy the needs of that particular human beings or not. So it is nothing but while defining a problem, it should be clearly who are the users and what are the needs of the users. According to that, we can design any component. We can go for the manufacturing. So it is nothing but determine what the mission should do, and includes user requirements and objectives, and forms the foundation for the entire design process. So it is nothing but we can collect the needs of the users, and who are the users we can identify, and according to that we can design a component. And next one is called, once your needs or aim is finalized, and then go for the what type of mechanism it should be required. So for example, let us take a IC engine. So what type of mechanism they were using? It is called a slider crank mechanism. So in that case, we can synthesize that mechanism. Synthesis is nothing but we can give n number of inputs. Okay, so we can get output without changing the dimension of the mechanism. So in case the dimensions of the mechanism will be changed, so it is not called mechanism. So it is nothing but we can give n number of inputs, it should be get output without changing the dimension of the mechanism. So generally we know that what are the type of mechanisms. It is called 4-bar mechanism, and one more is called slider crank mechanism. So select the possible mechanism or group of mechanisms which will give the desired motion. So it is nothing but we can give rotary motion, it should be convert reciprocating, or we can give reciprocating motion, it should be convert rotary motion. So it is nothing but converts need to possible design concepts, and choose suitable mechanisms like gears, linkage, cams. So generally different type of mechanisms are there with different based on the different type of applications. So what is called gear, and what is the linkages, what is called cams. So these are the different type of mechanical elements, and these are useful for the different type of applications. So for example, using a slider crank mechanism is an IC engine. So synthesis is nothing but we can synthesize the mechanism with the different inputs, it should be get output, but it without changing the dimensions of the mechanism. So this already aware of that in kinematics of machinery and dynamics of machinery subject very clearly explain about what is called mechanism and how it should be synthesized mechanism. So it is not the 3-position synthesis, 4-position synthesis. We can use Freudenstein's equation and Chebyshev spacing, and we can design the precision points, and we can find the link lengths of the 4-bar mechanism. So it is nothing but a fixed link and crank, connecting rod. So this is called synthesis of mechanism. So once the mechanism is finalized according to the needs of the users, then go for the analysis of the forces. Next, third one is called analysis of the forces. What is the need for analysis of the force? So find the forces acting on each member of the machine and the energy transmitted by each member. So it is nothing but determination of forces acting the machine components. So include load calculations, stress analysis, ensure safety and reliability. So example, calculating forces on a shaft in a gearbox. So what is the need of the analysis of the forces? So how you can analyze the forces? One concept is called free body diagrams. So it is nothing but while any component, let us take 2 force members are acting. Okay, so how we can analyze, and 3 force members, 4 force members, 2 force with 1 torque. So how we can analyze the forces? It is nothing but a resolution of forces. We can find the resultant force. At the end we can find the resultant force. What is the direction of the resultant force, and what is the magnitude of that resultant force also we can find. So it is nothing but analysis of the forces. So it is also called as a resolution of forces. We can analyze the forces in the different components of the system. So for next topics we can design components like shaft, gears, bolts, engine parts. Can explain clearly how we can analyze the forces in that components. So it is basically we can design and calculate the what are the forces are acting and what are the magnitude of the forces. And next one is called material selection, and fourth one is a material selection. So it is a very important how you can select the material. So why? Because the for example, let us take any component. The cost is very clearly depends on the what type of material we are using. So it is nothing but generally almost all 30 to 40% of the cost, it should be depends on what type of material we can select in the component. So that is the reason why the designer very clearly mention what type of material is suitable for components. So it is not select the material best suited for each member of the machine. So let us take any system, lot of components are there. Each component is manufacturing with different type of material. So how we can select the material? So generally we can select the material based on the force. So it is not based on the strength. So we can calculate the force. So it is nothing but strength is nothing but a stress. Next topics we can talk about what is called stress. Okay, mechanical properties. Stress or strength. So it is nothing but load by area. So load by area. Okay, so it is nothing but, obviously it is also called as a force. So it is nothing but we can calculate, first of all, you can do analysis of forces. So we can find the resultant force. So based on that only we can find the strength. So based on the strength we can select the what type of material is required, and cost. So cost is also very important factor. So I already told that any component, the cost is depends on the material first, and weight, and corrosion resistance. So weight is also very important. This is directly, it should be reflect to the density of the material. So nowadays everyone can talk about, we can design the component with lightweight. So it is what is the meaning of lightweight? It is nothing but they are using a lightweight material. Let us take example is called FRP, fiber reinforced composite plastic, or carbon reinforced plastics. So it is also called as a CFRP, carbon fiber reinforced composites, and glass fiber, GFRP, glass fiber reinforced composites. So it is nothing but it is a lightweight, and strength is high, and but cost is more, and it is also corrosion resistance. So many components are exposed to the open atmosphere. It should be designed for the corrosion resistance and impact durability and performance. So it is nothing but whatever the material we can select, it is a good durability and good performance. It is a performance is nothing but it should be perform different environmental conditions. Okay, and efficiency is also very important. And example is using steel for shafts and aluminum for lightweight parts. So the shaft is a very high strength component. Okay, so it is a dynamic member, so it should be required for high strength material, that is called steel for shafts, and aluminum for lightweight parts. So generally we can take any automobile body. Okay, so it is generally we can use for aluminum for the body. So why? Because it is a lightweight parts. So this is called material selection. And next one is, once force is okay, analysis of force is okay, and material selection okay, then next go for the design of elements. So this is very important for this subject. Okay, so what is called design of elements? So what we can design? So it is nothing but, obviously we can design size. So for example, let us take any circle. Okay, so how you can find the diameter? So without knowing the diameter, let us take a rectangle. So obviously it should be required length and width. So without knowing this geometry, without knowing these sizes, so impossible to design this type of component. So we know the diameter. So for example, let us take 10 mm. So it is easy to draw the circle. And we know, let us take a rectangle component. So obviously we know that what is a length and width of the component. So it is nothing but, these are the size is nothing but it should be directly related to the geometry. So we can find the geometry. The next session we'll talk about how do you find the geometry of the components while it is a 2D, while it is a 3D. So how do you find the geometry? Generally we can talk about design of any circular component. So we can find the diameter of the component. Okay, so how do you find the diameter of the component? So it is nothing but a size. And we know the geometry, it is easy to find the stress. So why? Because stress is nothing but load by area. We know that geometry, then it is easy to find the area. So generally we can use a circular component. So it is nothing but pi by 4 d square. So we can find the diameter of the component. So generally we can use called theories of failures while it is in 2D component and it is a 3D component. So how do you find the geometry of the component? We can use called theories of failures. That is called next class. Okay, so find the size of the each member of the mission by considering the force acting on the member and the permissible stresses for the material used. So already knows that material selection. So the materials, all materials already it is the data is available. So it is nothing but what is a material strength. So generally we can take it as a yield strength sigma y. So while it is in elastic condition, we can take it as a yield strength, and plastic condition, we can take it as a ultimate strength. So next class, we can talk about what is called material properties. So here we know that permissible stress. So that is nothing but stress regarding with the material strength. Maybe it is called yield strength. So again, yield strength in tension and compression. So again, it is called ultimate strength. So this is called permissible stresses for the material used. And one more is called force acting on the member. So considering the force acting on the member and the permissible stresses for the material used. Based on these two parameters, we can design a size of the component. It should be kept in mind, each member should not deflect or deform than the permissible limit. So it is nothing but whether your design, okay, whether your material is safe or not. So it is nothing but each member should not deflect or deform than the permissible limit. So we know that already stress strain curve. Okay, so each material, the stress strain curves are different. Why? Because each material, it should be fail under different conditions, under different strengths. So all members should not deflect or deform than the permissible limit. So below the permissible limit, then the material is safe. Okay, the design is safe. If the system is fail above the permissible limit of the material strength, so obviously it is not safe. So find the size of each member of the machine by considering the force acting on the member and the permissible stresses for the material used. It should be kept in mind that each member should not deflect or deform than the permissible limit. So it is very important condition. And determine dimension of the components considering the stresses and failure theories. Okay, we can use the failure theories and we can design the size of the components. And based on bending, torsion, fatigue, we can consider different conditions: bending strength, torsion strength, and fatigue strength. Ensures components withstand loads. So all components must and should be withstand the load. So we can design the all components for the, it should be sustain certain load. Okay, so obviously it should be withstand that much of load. So this is called design of machine elements, sizes and stresses. Next is modification. So once we know that sizes and stresses are finalized, and we can modify. So modify the size of the member to agree with the past experience and judgment of facilitate manufacturer. The modification may also be necessary by consideration of manufacturing to reduce overall cost. So once all the material selection, analysis of the forces and sizes, once it is finalized, and we can go for based on the past experience. So it is nothing but already some many components are there in the market. We can identify that all components we can study thoroughly. So whether it is the component, it is okay or not. In case it is there any problem, again it is possible to modify the dimension of the components or material selections and forces. So it is nothing but improving or refining the design based on analysis results. So we can use some FEA softwares. We can use some FEA softwares, ANSYS or Abacus, whatever it is. We can use some analysis softwares before going to the manufacturing. First, whether dimensions and stresses, forces are within the limit or not. So it is nothing but we can use some FEA, finite element analysis or simulation softwares, that is called ANSYS. So we can improving or refining the design based and analysis results, and corrects design errors, optimize performance and cost, iterative process. So example is reducing weight while maintaining strength. So obviously very important is reducing weight while maintaining strength. So we can maintain good strength, so reducing weight. So this is there any modification is required? This is called example. So once the modifications is also done, then go for the detailed drawing. So it is nothing but we can go for the CAD. So it is nothing but computer aided design. So we can use generally a lot of softwares are there in the market: CATIA, SolidWorks. Okay, so and Cryoparametric, Fusion 360. So generally these are the CAD softwares are available. So AutoCAD is also available for 2D drawings. So draw the detailed drawings of each component and assembly of the machine with complete specification for the manufacturing process suggested. So it is a preparation of technical drawings for manufacturing, includes dimensions, tolerances, surface finish, used by production engineers. So example is CAD drawing of the gear assembly. So once the modifications is over, then go for the detailed drawing. So it is not very CAD drawing is required for the components. So these are the general steps, and after that drawings over, then go for the production. So this is the last step in the phases of the design. The component as per the drawing is manufacturing in the workshop. So it is into the actual manufacturing of the machine components and assembly, and converts design into a real product. So converts design into a real product, involves machining, casting, fabrication. So these are the general manufacturing methods. So already knows about in your production technology subjects and manufacturing process. You know that already what is called machining and casting and fabrication. Example is manufacturing process using CNC machine. So very high precision equipment. And this is called production. So this is related to the manufacturing point. And summary, mission design starts with identify the need. So it is very important. So we should identify the need based on your users, or you can identify certain number of users. Based on that, we can identify the needs, and based on the need, we can move to the mechanisms and analysis, material selection and design. Ends with production of final product. So it is an iterative and systematic process. So this is the summary of the phases of the mission design. Now we can take one example and explain this all phases of the mission design. So example is design of screw jack. So generally we can what is the purpose of using a screw jack is used to lift heavy loads like cars. Generally any automobiles we are using a screw jack. The purpose is lift the heavy loads like cars. How we can design this screw jack? By using these phases of the design. The first step is need or aim. So what is the need or aim? So before going to the design of the screw jack, so first what is the need or aim of that component? So identify the problem and define the objective. So we can design the screw jack. Generally we can use the screw jack while any automobile is in puncture. So obviously we can use the screw jack and we can lift that vehicle and we can change the tire. Okay, so it is to identify the problem and define the objective. Need, lift a car safely for maintenance. So it is nothing but I am designing a screw jack, lift heavy loads like cars only. Okay, not for buildings. So generally nowadays we can use jacks for the lifting the buildings also. Okay, so that is the reason why my need is lift a car safely for maintenance. Okay, so aim is design a portable screw jack capable of lifting 2 tons. So generally all automobiles using a screw jack, it is a portable screw jack. So generally carry that screw jack in the automobile. So if there is an emergency or it is in a puncture case, we can lift that vehicle. So it is nothing but a portable screw jack. So we can use that portable screw jack and capable of lifting 2 tons load. Only I am designing for cars only. Okay, this is the way to identify a need or aim. So it is nothing but clearly shows what is the problem. Designing a portable screw jack capable of lifting 2 tons. So need is lift a car safely for maintenance. So this is called need. And based on that, what is the mechanism? So what type of mechanism we can use? Mechanism selection. So that is called synthesis. So select a suitable mechanism to achieve required motion. So it is nothing but obviously the mechanism is nothing but it should be only convert one form of motion into the other form. So it consists of links, joints. So mechanism chosen I am using as a screw mechanism. So generally very simple mechanism is called a screw mechanism. So I am using called a mechanism chosen is screw mechanism. Why? Because it should be converts rotary motion into linear motion. So generally we can use a lever. Okay, so we can give rotary motion. So it is nothing but we can give some rotary motion. Okay, so it is nothing but convert the rotary motion to the linear motion. Okay, then only it should be lift the cars. So it is nothing but that is the reason why the screw mechanism, the particular purpose of using the screw mechanism is converts rotary motion into linear motion. So I am selecting as a mechanism selection is called screw mechanism based on the need aim. Okay, then once the mechanism is finalized, okay, it is a very simple mechanism. Okay, so next third one is called analysis of forces. So I already told that I am lifting a 2 tons load. 2 tons load I am lifting. Okay, aim is design a portable screw jack capable of lifting 2 tons. So how we can analysis of forces? Calculating the forces acting on components. Okay, load on screw. So generally how much load is acting on the screw is 2 tons. So it is nothing but a 20,000 newtons. So it should be converted into the newtons. So it is called 20,000. Okay. Determine torque required to lift the load. Okay. So it is nothing but torque. So it is something torque equal to force into perpendicular distance. So it is nothing but a some R. Okay. So it is nothing but we can use a lever. Okay. And we can give a rotary motion. Okay. And it should be converted the linear motion. So this is called radius of rotation. So generally we can use radius of rotation. And force, load on screw. So how much force is acting? So it is nothing but a 20,000 newtons and radius of rotation. So it is nothing but based on that we can determine torque required to lift load and consider friction in threads. So generally we can consider a friction, minute friction we can consider. So this is called analysis of forces. Generally the screws are also different type of screws are there, square threads, acme threads, okay, buttress threads, different type of profiles are there in the screws. Okay, so analysis of forces based on the load. Okay, so it should be converted to the force and determine the torque required. So this is called analysis of the force. Next, based on that we can select the material selection. So it is very important. Choose suitable materials based on strength, cost and durability. Okay. So generally the screw is a very high strength material is required. So it is nothing but we are using a high strength steel. Okay. And generally we can use nuts. Okay. In that screw jack. So it is nothing but a bronze, good wear resistance. Okay. So while it is given any rotary motion, okay, for the lever, so it should be required consist of some screws. Okay, screws and nuts. So the screws are required high strength steel, and nut is very important properties. Wear resistance is required. So that is the reason why the bronze is very good, suitable material for the good wear resistance. And base, the generally the screw jack it consists of the base. Okay, so this is called base, and this consists of the screws. Okay, we can give some rotary motion, and this base is generally we are using a mild steel. Okay, and screws are made up of the high strength steel, and nut, okay, it is important for the wear resistance. So good wear resistant material is bronze. Okay, so based on the components, what are the components are there in the system? So according to that strength and cost and durability, we can select the materials. Okay, so once the material selection is over, then go for the design of elements. Okay, so it is the sizes of this all screws, design of the screw, nut, base. Okay, so determine the dimensions of each component using design equations. Okay, so it is not what I already told that the definition itself, some technical specifications required for design of the any systems, any components. So it is nothing but determine the dimensions of each component using design equations and calculate core diameter of screw. Okay, so some further topics are there. Design of bolts. Okay, so in that case, how you can design the core diameter of the screws. Okay, and check compressive stress and shear stresses. So generally identify the components failure under what type of stresses. So generally the screws are fail under compressive stresses and shear stresses. Ensure factor of safety. So this is very important. Okay, so it is nothing but let us take 2 tons of load. So we can't give an assurance for exactly lift 2 tons of load. So we can use some safety factor. Okay, so next we'll talk about different type of material properties. In that case, what is factor of safety? So generally we can use some above 1, okay, 1.5, 2, like that we can use some factor of safety. So let us take a 2 tons load it is lifting. So we can use 1.5 factor of safety. So it is nothing but so obviously it is not exactly lifting 2 tons. Okay, so that is the reason why every component it is given it is using some factor of safety. So why? Because it is very important for safety of the components. Okay, so that is the reason why ensure what is the factor of safety. So it is also how you can design the factor of safety. We can use some theories of failures, static theories of failures and fatigue theories of failures. Okay, Rankine's theory, okay, Tresca's theory, von Mises theory. These all are for static failure theories, and Goodman's, Gerber's theory. These are all called fatigue theories. So based on the theories of failures, we can design a factor of safety and determine the dimensions of each component. We can use some certain failure theories. Okay, and based on that, we can design each component sizes and calculate the core diameter of the screw and check strengths. I'm considering a strength is called compressive stress and shear stresses, and ensure factor of safety also. It is very important, it is mandated. So once the design of elements, sizes and stresses are over, then go for the modifications. So improve the design based on analysis. So once this all we can finalize, what is the materials, what are the sizes and stresses, we can use any analysis software. Okay, so improve the design based analysis, increase thread size for safety, and reduce weight by optimizing base design. So it is nothing but an entire screw jack, the base is more weight. So in case reduce weight by optimizing base design. Okay, in the screw jack, is there any chance to reduce the weight? Is nothing but optimize the base design. Okay, improve handle length for better torque. So it is nothing but improve the lever length. Okay, so it is also the lever length is also exactly design. So what is the length of the lever? So why? Because improve handle length for better torque. So why? Because the torque equal force into perpendicular distance. Okay, so this is the very crucial role. So it is nothing but we can't control this force. Okay, so we only focus on what is this perpendicular distance only. So that is the reason I improve handle length for better torque. So modifications, it is very important. So improve the design based on the analysis. So based on the analysis, increase thread size for safety and reduce weight by optimizing base design. Improve handle length for better torque. So these are the modifications based on the analysis. Next, once the modifications is also done, then go for the detailed drawing. So it is nothing but prepare manufacturing drawings with full details. So it is nothing but draw screw threads with dimensions, specify tolerances and surface finish, assembly drawings for screw jack. So generally this detailed drawings, it is under maybe it is in production drawing practice, PDP, okay, and mission drawing. So in the two cases, especially explain how you can specify the tolerances and surface finish, assembly drawings of the any system. So it is nothing but assembly drawings of the screw jack, draw screw threads with dimensions. So we already knows what are the dimensions, already designed. So according to the dimensions, we can design the screw threads and specify tolerances and surface finish also for that components, and assembly drawings for screw jack. So it is nothing but we can design lot of different components. All components we can assemble, and finally we can design screw jack. Okay, so once the detailed drawing is over, then go for the production. So it is nothing but manufacturing and assemble components. Mission screw threads. So generally the screw threads we can manufacturing based on the machining. Okay, machining process, and base will be design manufacturing based on the casting. Okay, good strength, and assemble screw, nut and handle. So it is nothing but we can manufacture screws, okay, screw threads by using a machining process, and we can manufacture the base by using a casting. Okay, we can assemble this all screw, nut and handle. So this is called production process. So these are the phases of the mission design. So how we can use these phases of the mission design. So this is a one very simple example, design of a screw jack. Okay, so this is only for basic introduction about the mechanical engineering design only. So the first topic is phases of the mission design: need or aim, synthesis or mechanisms, analysis of forces, material selection, design of elements. It is also known as a size and stresses, modification and detailed drawing. So these are the major phases of the design. So next class we'll move to the what are the properties of the material. So why? Because here we can design standard components. We can design a standard component. So that is the reason why we are not discussing about any need or aim. Okay, synthesis of mechanisms. So already knows in the kinematics of machinery, dynamics of machinery, already knows about what is the synthesis of mechanisms. So that is the reason why the mission design is most of all after completion of the mechanics, strength of materials, kinematics of machinery, dynamics of machinery, and metallurgy subject, then only we can go for the mechanical engineering design. So that is the reason why need or aim. So we design for the standard components like it is a gear, belt drives, shafts, bolts, engine parts. So it is nothing but a connecting rod, piston. Okay, so that is the reason why we are not talking about need or aim. Okay, synthesis of mechanisms already completed in your previous subjects, kinematics of machinery, dynamics of machinery. Analysis of forces already knows about in your engineering mechanics. Okay, so in dynamics of machinery is also there, you can resolve the forces. And material selection, so it is how you can select the material based on the mechanical properties. So based on the mechanical properties we can select a materials. So next class we'll talk about little bit about material selection. So based on the material properties. Okay, so once the material properties is okay, and then talk about what are the standards and codes, okay, and preferred numbers, then we'll move to the design of elements. So it is nothing but how we can design sizes and stresses. So we can use certain principles and certain theories of failures, introduction about the theories of failures. So how we can use theories of failures for the design of the sizes and stresses. So mainly we can focus on design of elements, so in that phases of the mission design. So modification is nothing but once your design is okay, then you can go for the analysis, and if there is any modifications you can modify. Once the modifications is okay, then go for the detailed drawing. So it is nothing but CAD models, then go for the production. So in that entire phases of the mission design, fully focused on the design of mission elements. So already need or aim, synthesis of mechanisms, analysis of forces, and material selections are already over in your previous subjects. Okay, so this is an introduction about the mechanical engineering design. So in that one, the phases of the mission design is very important topic for the basic of the mission design. So thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.